Hello and welcome to my today's talk titled Design-centric approach to creating tools in 60 parsecs and 60 seconds Reatomized. My name is Mateusz Pusty. I work as a gameplay engineer at Robot Gentleman. As the title of this talk says, I've worked on both 60 parsecs and 60 seconds Reatomized. I am also one of the organizers of Unity Developers Meetup in Poznań and an all-play game jam, an event that is focused on raising developers' awareness about accessibility in video games. You might be wondering if this is the right talk for you. If that is so, then wonder no more. Basically, if you're interested in the 60 series, like technical postmortems or think about developing custom tools in Unity, then you are in the right place. So let's jump right in. First, before we'll talk about how the game was implemented, it's good to know what the game is actually all about. 60 parsecs is a spiritual successor to the game called 60 seconds. Both of these games share the same fundamental gameplay, although they differ in the setting and specific mechanics. Both of these games have two types of gameplay. First is called scavenge. During this part, you need to collect as many items or characters as you can within the 60 seconds window. If you don't, you're going to burn in the fires of an exploding atomic bomb. Second type of gameplay is called survival, and it is focused on delivering a more adventurous type of experience. You need to manage your resources and make decisions that can affect you or anyone around you. The ultimate goal is to be rescued, no matter if it is from an atomic wasteland or an emptiness of the space. Let's now look at both scavenge and survival gameplay, and then we can move to more technical stuff. Let me show you a short video presenting the gameplay. As you can see from the footage, the scavenge is a 3D scene with billboards serving as environmental decorations. We are running around the space station and we need to collect as many items as possible until the clock on the upper right corner finishes its countdown. Beware that we have a limited amount of items that we can carry at one time, so plan your route carefully. Remember to reach the shuttle evac point before the nuke comes. Afterwards, if we've managed to get to the shuttle in time, we are greeted by the 2D environment. We can notice all of the items and crew members that we have collected. We also have some space shuttle systems present, such as expeditions or crafting that will become available at later stages of the gameplay. We can open the star log to read the outcome of previous day events and check the well-being of our crew, see the goals that are ahead of us, read about the people we have aboard on shuttle, and see the statistics for our current run. Next, we can make an attribute-based decision. The better we are at a given attribute, the more probable is the good outcome. We can also ration food to each of the members of our crew, and if we're done, finish the day. But beware, the dangers lie ahead of you. One bad decision can easily drive someone mad, or even worse, result in character's death. Alright, I tried to sum up the core gameplay of the game into one neat flowchart. The game starts with the scavenge phase. If we don't die during this phase, the game transports us to the survival. Every day spent in the survival, we need to make decisions to the occurring events. This continues until we reach some sort of resolution, no matter if it is everyone's death or if we've just been rescued by an alien race. During the development of 60 parsecs, we had one main technical goal, other than finishing the game, of course. It was to develop it in such manner that the designers will be able to implement new content with minimal input from the coders. This would allow us, as our resources were unfortunately not unlimited, to focus on other technical challenges, and at the same time, give designers free hand when it comes to implementing content and content-related logics or assets. At this point, I'd like to remind you that when we first started developing the game, it was in early 2017, so we didn't have such things like bold, shader graph, or nested prefabs that can be now used free of charge by anyone who's using Unity. First thing that proved challenging, at least for me, was managing both the gameplay mechanics progress as well as the tools that were needed to be developed. At the initial pre-alpha stage, I was the only coder on the team that was actively developing the code base for 60 parsecs. It's worth noting that even though I had some experience with professional game development in Unity, I was, and I'm probably still a little to this day, flawed with many issues that people at my stage of career are. One of those things was most definitely the knowledge that I can do anything. The other challenge, at least at the beginning, was that in reality 60 Parsecs wasn't just one game. Mechanically speaking, Scavenge and Survival are two very different games that require different approaches to the development. Although the Survival mode has much more mechanics and systems, the Scavenge was, for example, a more challenging to achieve visually. At the moment, my focus was almost entirely set on implementing the survival part of the game, and we've eventually decided to outsource this Scavenge to our friendly neighborhood developers from Monster Couch that we have a pleasure to share our Pyramida Hub co-working space with. Finally, the last challenge was time. We had to create the pre-alpha version of the game in time of the local game expo, Poznań Arena, where we were planning to unveil the newest title to the audience and let them play the early version of the game. At this moment, you already know that the majority of the game is spent during the survival mode, so that's where my efforts were placed the most. The data that we store in 60 parsecs can be easily grouped into three main categories. The first categories are entities. This is all of the information, both design time and runtime, about items, characters, visuals, or even the loading screen posters. Almost all of these entities are singular, meaning that, for example, there is only one shovel at the scene. But sometimes these entities are of a similar data types. For example, both shovel and gun are items, so both of them can be crafted, recycled, used in event, etc. The second category are managers. They are very similar to the entities in a way that they are also singular, but they are actually much more complex. They are designed to handle much more complicated mechanics and provide methods to use these mechanics in-game. An example of such a manager could be a crafting system. Finally, the third one are events. This is the bread and butter of our architecture. Events provide the way for designers to implement their visions in the game. They are node editor-based canvases that have specific roles. As an example, survival event is used to display a decision to the player and provide the immediate outcome of the player's choice at the very next day. All of this data is implemented in a spirit of scriptable object architecture, which allows us to create a common environment for designers to work with across all of the available data. So what is the scriptable object architecture? Well, this is a topic that is very wide and has its own dedicated talks that I can wholeheartedly recommend to you. But for those at all unfamiliar with it, here's a quick refresher. In order to know what the scriptable object architecture is, one first must understand what the scriptable object is. Unity manual says, a scriptable object is a data container that you can use to save large amounts of data independent of class instances. But it's much more than that. In reality, they are scriptable asset files that allow you to store data and even logic outside of a mono-behavior component. Their data is also not reset after exiting play mode. And again, please remember that this was in 2017 and things such as entity component system were in a rough prototype phase presented on the stage of the Unite. But scriptable objects are basically ideal for our use case. We can create a scriptable object script that defines the item and then create the asset file for each item we have in a game and only change the data of it. Then we can reference this data in mono behavior and control them accordingly to the data from the assets file. And that is basically what the scriptable object architecture is. Instead of keeping the data in components, we keep this data in asset files and thus separating the data, and in our case logic as well, from visual representation on scene. This way we can reference the data from any scene without having to implement cross-scene references or anything like that. But there is a small issue though, because the scriptable objects are not reset after exiting play mode, and naturally they also keep the data alive for the entire of-game process. This will lead to many situations where the logic has changed something and the data persists even if we have reloaded the scene or re-entered play mode. Luckily, there is a simple solution. The solution is to have some sort of Unity or C# event. In our case, it was a save event, to have the scriptable objects registered to during their on-enable. Then we can simply invoke this event when we are trying to start the new game and we need a fresh set of data, or we're loading the game and want to have the serialized data instead. And because we were actually storing the entire logic for the systems inside these scriptable objects, we can easily use them to access their data or invoke their methods from things like nodes or user interface. Additionally, this allowed us to create one directory named design. The underscore is so it shows up on the top of the hierarchy in the project view, and keep all of the data available to the designers in one place. Sometimes though, our scriptable objects had so much information that it was very hard to set it all using the default Unity inspector view. In such cases, we've implemented custom editor to make our designers work a little easier. And as you can see, the runtime data on the provided screenshot is even grayed out if we are not in play mode. Okay, we have talked about the entities and the managers. Now it's time to talk about our biggest gamble, the events implementation. And in order to give total control over to the designers, we've decided to implement a node editor-based system. We had three main requirements for the node editor. First, it had to be easily extendable, meaning that we can create our custom nodes, canvases, and everything else we need without too much of a hassle. Second, it should be easy and intuitive enough for the designers to understand without the need for the extensive documentation. Because, as we all know, writing documentation is a very hard and time-consuming thing to do, and it's not always on the top of the priorities list. And last but not least, it should give us a total control to redistribute it if we've ever decided to polish up and release the tools to the community in the form of a modding toolkit. First place that we looked at for the solution was the asset store. The obvious solution would be a Playmaker, but I've never personally been convinced of the way it was designed. I didn't think it was intuitive enough. As I was actually quite fond of Unreal's blueprints, I was very tempted to give Notorus a try. Nowadays it's completely dead, I think. It was basically a blueprint clone implemented in Unity. Pretty neat. Unfortunately, it was also very expensive and hasn't been maintained anymore, so it was a no-go. As all of these solutions from the asset store also fell under the asset store EULA, it was unlikely we'll find the one that will meet the third point of our requirements. That was the moment that I started thinking about the custom solution, but remembering the first and third challenge, I knew that there is no way to have anything that will be useful enough in a given period of time. So I've started looking for some sort of framework that could be used to implement our own solution much quicker. And there it was, Node Editor Framework. It was still work in progress but had most of the basic functionalities that a node editor needs already implemented. That meant that at least I wouldn't need to implement everything from scratch. On the plus side, the project was, and actually is, still under active development, so we're able to pull some fixes or new features periodically. It was also very easy to expand it. It was designed to be a blank space for other developers to implement their tools with it. And finally, it was available under the MIT license. So after a quick test run, I've created a proposal, a visual event editor prototype design document. It had about 20 pages, and back then I thought that at least for the alpha version, there will be about 20-30 nodes available, and creating a working code base would take about a month. Remember when I said that I thought that I can do anything? But as life goes, there were some issues with it that were surfacing the further the development went, and most of them had to be resolved. First, there were a lot of functionalities missing that were preventing the tool to work outside of its concept phase as effectively as I hoped. It had its share of performance issues that have appeared as we've added more and more content to the game. Even though creating nodes was easy, it was slow and tedious, and some solutions had to be implemented to improve upon this process. The code was mixing editor and runtime classes, which made it prone to build errors as we've been adding new nodes and features because of forgotten if Unity director preprocessor directives. But it worked eventually. Only at the end, near the game release, it had about 300 nodes instead of the 30 I thought initially, and the total development time was closer to 6 and 8 months of work because of everything that had to be implemented, refactored or fixed in order for this tool to have most of the features we needed. But at the end, it actually looked pretty close to the version I've envisioned in my final design document. As you can see in this comparison. As the development went and we've stepped out from the free alpha phase, we've actually increased the team working on this game from the initial 3 to more than a dozen, including 2 additional programmers. We were able to divide the work more evenly and implement all of the gameplay systems and mechanics, and I was able to focus some more time on implementing the node editor and even editor features that we needed to complete the game. Then we've reached the magical day of 18 September 2018, when we've released the game to the public, grabbed a breath of fresh air, and we immediately had to jump back to work in order to bugfix the game. Short summary up to this moment would be that indeed we had released the game. Almost all of the content and gameplay logic was implemented by designers, and the game was prepared to receive some new content along the way. But it was at the cost of huge delay because of the development of Node Editor. Because of it, the design team had a late start when it came to implement the actual in-game content from design papers. This led to a lot of content bugs that were very hard to locate, as we didn't have a good method for testing the content, other than actually playing through all of the outcomes, and for that, there simply wasn't any time. But we did actually resolve a lot of these issues. So now comes the time to test if we've achieved the main technical goal. So far, we've released 2 major content updates to 60 Parsecs. For the first one, we've actually had some programming work to do, mostly because of the new missions mode that had to be implemented, but the missions themselves were implemented completely by designers. The second one, an additional mission, was created without almost any programmer's involvement whatsoever. But the real trial by fire for our approach came in the form of 60 seconds Reatomized. Let's just watch the trailer so you know what it is all about.
Meet Ted, Dolores, Mary Jane, and little Timmy, a true American nuclear family. How do you do, fellow family? What was that, Ted? I can't hear you over the sound of the nuclear bomb alarm. The nuclear bomb alarm? There. Remain calm. There is plenty of time to take cover. You've got 60 seconds. Reatomized. Make it count. Soup, water, supplies, and everything nice. Oh, I almost forgot. Make room for the family. 3, 2, 1. Duck and cover. Welcome to your fallout shelter. Make yourselves comfortable. You will be staying here for a while. It's time to ration food and water. Send expedition to the nuclear wasteland. Cope with unexpected situations, making decisions that will affect your future. And maybe survive. Or not. Well, hello there! Ted, Dolores, Mary Jane, and little Timmy. A true post-nuclear family. It might just be the fallout, but you folks are positively glowing. Enjoy living the radioactive American dream. The government does not guarantee an enjoyable radioactive American dream, but it can deliver on amazingly improved views, sounds, and hats.
But how does this game compare to the original? It is an almost complete remake of the 60 seconds on a 60 parsecs codebase with 4K graphics. Somewhat funny is that when we initially released 60 parsecs, there were some voices from the community that we have simply taken the original 60 seconds game and changed the graphics and texts. As you can see from the stock, it's very much not true. But we've actually done something like that when we were making the 60 seconds Reatomized. We still had a lot to do, but essentially we have recreated the original game using 60 parsecs as a starting point, which saved us a lot of work and makes it easier to maintain both games in the future. The improvement list includes an entirely new menu with metagame functionalities, remastered scavenge mode with new character control, completely remade survival based on a 60 parsecs architecture, new survival challenges mode thanks to the missions from 60 parsecs. And when we've decided to create the Reatomized version, it was where the scriptable object architecture and node editor really shined. As the game system's logic, for example rationing, actually were very different from the logic of 60 parsecs and would require rebuilding this logic in code from scratch, this was actually done almost entirely in periodically run events. Even though both of the games are very similar, we had to rewrite the logic of a lot of gameplay nodes. But almost all generic nodes, such as ifs, calculation nodes, etc., were transferred almost entirely one-to-one. The same happened with a lot of other systems. Expeditions required modifications, but they were actually very similar to their 60 parsecs counterparts, except the locations were chosen at random in the Reatomized. We have made a lot of improvements to the node editor itself, especially in the way that the nodes were created. As a lot of bug fixes for the codebase were already implemented with 60 parsecs, this resulted in a much more stable game during the release. But we've managed to find a few more bugs that we fixed and later backported to 60 parsecs. We've released 60 seconds Reatomized on 25 July 2019, which happened after 6 months of development. We initially planned to release this game even sooner, but we had some delays on the way. For example, figuring out the gameplay logic of the original 60 seconds took a lot more time than we initially thought, because a lot of the logic was actually hard-coded in the game itself. Summing up the talk, creating big tools for your game development is a huge risk that may or may not be actually worth it. Always think that this will take you a lot more time than you initially thought, because as the game grows, the tools would need to grow as well. You'll always encounter some bugs, or will have feature requests from your designers that you have never thought of before, or simply some things will take a lot longer than they should, because the Unity editor codebase is not something that is particularly easy to work with if you decide to work on some more advanced stuff. You can have a huge flexibility and power to implement a lot of your designer ideas. This can be a huge help during content creation, but you always need to think if the time that will be spent on developing this feature will pay off with faster content creation. Not only that, but be sure that the tool will be finished in at least MVP usable state before the designers will actually need to use it. Always try to use or modify existing tools before you try to create something from scratch. Even if you fail, you can learn a lot about how something was solved, and then if you really need to start from scratch, you'll be able to avoid some of the mistakes. And remember, after you venture on this kind of journey, there will be no coming back, and you'll be creating small editor improvements, such as scene autosaves or copy-paste of assets in the project window forever. That is all from me for today. Thank you very much for tuning in on this talk. I hope all of you are able to stay safe during these uncertain times and that you're able to cope with everything that happens in the world. I encourage you to check out both of the games I've been talking about, and if you have any questions, feel free to reach me via email or Twitter. Have a great day, and I hope that there will be a safe way to meet soon.